Hello, everyone. Welcome to our presentation. I hope that lunch did not kick in yet, so at least we have some energy and space to consume what we are discussing today. First of all, thank you for joining in. I would like to have this presentation more interactive. So that means that at any moment in time, you are more than welcome to just raise your hand to ask a question. It's always a bit more fun and also to stay awake after lunch. Out of curiosity, do we have any Greeks in the audience? Oh, good. Then I don't have to change all my slides. My name is Charalampos Xanthopoulakis. Probably only the guy over there could read my name properly. I am a data visualizations architect. With this buzzword, I can explain more what it means. I'm working for ASML, and today we're going to talk about how we can use our data to tell stories. So I hope I'm not disappointing you today, but we're not going to be writing any code. So, word of warning. So you don't need to open your laptop. You don't need to type in anything. We can always explain a few more things later on. But today is about the thinking process of how really we can use what that buzzword means, the data, into really write and make meaningful stories with data visualizations. At any moment in time, if you have a laptop, you can always log in and navigate to my blog, infographico.com, and you can take a look at most of the visualizations I will be describing today. So a few things about what I'm actually doing here. My name is Charalampos Xanthopoulakis. I did not really work as a data visualization architect from the very beginning. In fact, I studied electrical and computer engineering in Greece, in Thessaloniki. That's the birth town I come from. I took my diploma from there. Then I went to the University of Eindhoven. I studied also software technology. I worked for many years from Philips Research, grew up towards as a software architect. And then when the next bridge that came into mind, together with my fellow Astrid, we work in ASML about data visualizations. What I found out, especially the last couple of years that I've got to travel and to meet with different clients, also from Philips, from ASML, but also other projects that I have been going on. What I got to understand, and I hope you can also agree with me, that data actually is all around. How many of people in this audience work with big data in your daily life? Can you just, by raise of hands? Okay. Data in general, I would say that's is quite common. People talk about data a lot. It's quite a buzzword. Deep learning, big data, processes, showing it, like the knowledge and all the value in it. But to my expectation, or at least what I have figured out myself, is that the fact that you have data or big data doesn't really necessarily make you richer. I want to ask this question: If tomorrow you realize that below your house there is a gold mine, are you rich? I tend to agree that you have the potential of growing rich, but you're not instantly rich. I mean, if you need to yourself be able to dig into the ground, try to reach where your gold mine is and try to extract it. And then even if you extract it, you need to take it out, you need to process it, you need to go through some thermal processing, and then finally you're able to grab that gold, and then you say, now I'm rich. Guys, this is exactly the same story with data. Just the fact that in your company, people, like your manager says, we have this amazing logger, and we are now able to log in to capture all the logins of our users, or that we are able to measure how much time people spend on our website. That doesn't make you rich. That doesn't make you more knowledgeable. It just says that you have a big database of data, or you have some huge files, CSV files or XML files, and now that's the tough work that starts. Because just like having the data or even showing somebody an XML file really doesn't say anything. The same thing that if I tell you that I have a gold mine below my house, which I, by the way, don't, that doesn't make me rich. And what we have been doing in the couple of years, especially like the project I have been working on, is that how can we use this data in a way that we can present it to our end users in a way that they can understand, they can make meaning. So I like to use the metaphor that data is a bit like raw ore. It's like a stone. It's only after you carve it and you process it, you extract it, that you really make a story out of it. That leads to knowledge. I have an actual situation that was from Philips research. And this is how data tells you how active you are every day. So what you are seeing in this plot in here, this was made by D3GS. How many of people have heard about D3GS? Okay, so for the others, D3GS is one of the most powerful JavaScript libraries that you can use to materialize, to bundle data, and to help you build meaningful visualization in terms of plots. But D3GS allows you to process it, or to manage your data, to show different graphs. What you see in here is actually one of the situations that for Philips we were coaching a number of people. So we were running a pilot, and that pilot was about COPD patients. COPD are patients that have a problem with their lungs. So it's called chronic obstructive pulmonary disease. It pretty much means that your lungs are failing, and you have a very big difficulty in taking your breath. So most of the people are actually quite like around their 60s or even older, 60s, 70s, not very consumed with technology. So we still wanted to help those people, to coach them so that they can monitor their health remotely and be more active. So what you're seeing in this diagram is actually, you understand flams or Dutch, right? So you have the months, January, February, March. These are the months of the year that we run this pilot. Every segment in the circle below, in the inner circle, this is the week. And every circle on the outside, that's every segment that refers to one day of the year. What we did then, we gave them activity monitor, something like Fitbit, one of the applications from Philips. And we asked them to run a number of exercises, like walking, and some fitness and some stretching exercises. So what you see in here, every red segment actually signifies that this is the time of the period that these patients were actually running below their average. So we had them like some threshold. They say, this is how much active you need to be. And then red means below, blue means okay, and green means above average. What this diagram actually showed us, I don't know how many people can interpret it. What this actually showed us is that starting the pilot in January was a pretty bad idea. A pretty bad idea. Because you start with a lot of enthusiasm, you say, we want to coach people, you want to bring them into this activity, and then you see that they start the first period of the year running below average, and you can understand it. But only when you visualize it, we actually managed to find this true. That when you capture the data and then you visualize, you saw, whoa, okay, so January, that was a pretty cold time. That was difficult for people to be following upon. Then, as time went by, then you see that we had quite an improvement in February, March. So as we go during the summer period, actually we see that they are able to cope with what we said. I need you to look at this diagram because there are no numbers in here, no numbers at all. And if you are talking, when we are talking about data visualizations, a data visualization doesn't need numbers. In fact, they might not even need text to convey the message. Just by showing it, you can actually convey the meaning that, look, this is how you did all year. And this goes cross-age, it goes cross-gender, it doesn't really matter. It shows you already instantly, just by using color and geometry, how you are doing it. I want to invite you to look into another visualization. This is also the data of another patient. So in here we tried to do something different. So we took, again, the year, and then every black dot that you see corresponds to a time, like a period of minutes that these people were active. And then we tried to plot it. So every line that you see is actually a day, like 24 hours. And then we try to plot it all around the year. Do you also notice that same thing? Like in January, again, activity was not that high. And as we grow towards the summer, look at this. Look at how much more activity we have. The blank spots means that like between March and April, or between August and September, or in October, it also means that for some reason that time people were sick, or some of them even lost the device. So they were not able to walk. And that already is a signal for you to look into what is happening. What does this look like? Come on, we can talk. What does this look like? The iris, the human eye. This is also one of the examples that data visualizations are also, it's not just about writing code. This is also how data visualizations are kind of mapping with art at some point in time. Can somebody explain me why we have so much white space in the middle? Sleeping. Sleeping, exactly. And then you can also look at this, or there were some periods of time that people had difficulty in sleeping. So, but still, many of them were even committed. They would, like, there was a small device that you would just put it in your pocket or around your neck, and there were people that they were even using it the entire day. I can tell you that a diagram like this gave rise to another application that came also at that time from Philips, to start also monitoring the sleeping cycle of people. So exactly because people were willing to use that device also while during the night, they were able to see how are these people sleeping, or how does sleeping actually has an effect on their daily life. You also see that in the other interesting thing. If you look at June, July, August, you also see that people tend to stay longer awake. So people tend to walk or use more the activity. That also is because this trial was running in the Netherlands. Well, you know that during the summer, it's the light is on until like 11 o'clock. Again, from Greece, I found it really interesting, to be honest. But for many people, that as the day was longer, it also gave them more incentive to also stay longer and use this device. So when would you start a pilot next time? I would say that you would prefer to use the summer period. Then you also can capture more information about it. Out of curiosity, has anybody on the audience ever worked with a data visualization? Have you ever made a data visualization? And please don't tell me I use Microsoft Excel. Please, can somebody has used something other than Microsoft Excel to make a visualization? Kibana, nice. That's quite common, quite popular. Any other tools? Pure JavaScript. Somebody has written anything in JavaScript? Again, which?
We work with many libraries, but it was also the D3, I think, we were using for presenting all the graphs that were collected during the how many visitors were at what time in the fitness studio, the gym.
So this is actually one of the nice things. D3GS is only one way of building a visualization. For me, respect, honestly. So D3GS has quite some learning curve, but you can do some amazing stuff over there. But there are also other tools. Did somebody use Spotfire or Tableau before to build a data visualization? Oh, not so many on the vendor part. Okay. To build a data visualization, for me, if you ask my humble opinion, you don't need to be a data visualization architect. I truly believe that, and also looking at my path, I started as an engineer, towards a developer, like a software developer, and exactly because I was in touch with this kind of data set, I was inspired to look into deeper things. And to be able to build a data visualization, I think you don't need to be even that elaborate in graphics. Can somebody explain me this diagram? What does this mean? Astrid, can you help? Again, similar case, the pilot we had with the COPD patients. We gave them this activity device, but apart from beweging as the activity, we also asked them to do some stretch exercises and also some strength exercises. And again, no numbers, really no figures. We wanted to convey the message, how am I doing? How is my health doing? And just by drawing a few boxes and dots, we were able to explain them to people that haven't used a computer in their entire life. How is it that I am achieving? And this actually diagram showed another truth, is that with movement, we saw some people that they were looking at these diagrams, and then they said, well, onvoldoende, I did not do enough, I need to do more. And they started doing more, they started exercising more, and they're like, they felt out of breath, and then that had an impact on how they're doing. So by this diagram, we are showing that strength was pretty difficult for them. They would just do the bare minimum. And with flex exercises, yeah, that had its ups and downs. So I was able, but then I could feel some pain. Then I was not able to do that again. Then I was trying again. So that had an impact. It is really important that when you read these diagrams, you use these diagrams to change your behavior. The highest level of a data visualization is gaining knowledge, understanding new things, getting insights. And that already means that perhaps maybe we were too tough on them and that maybe we should give them more incentives, maybe start slow and help them, giving them like a steady behavior. Often what you do is that when you join a different company, when you embark into different domains, you come up with new insights. You come up with a completely different domain. I was working for Philips for 6 years, so I was used to working with medical data. Then I went to ASML. How many people here know what ASML is? Not bad. Well, I'm embarrassed, but I cannot explain exactly what ASML means, but L is for lithography. So ASML is one of the leading providers for lithography systems. So one of the leading providers in chip manufacturing. So what ASML is doing is that we build the machines that many customers around the world, like LG, like Samsung, like Intel, they use to generate their own chips. For those who may not be familiar, chip making means pretty much taking a wafer, and as a wafer, not these stroopwafels. Actually, it looks a lot like a stroopwafel. For those who haven't seen it, it's actually a round disk. That's 30 centimeters diameter. It actually, if you look at it, it looks like a wafer because it has this grid system on it. And this is made of silicon. And pretty much what you do is that you have this disk, and this is exposed with a laser, so the machine is moving the disk in different locations, and then you burn the silicon when you want to build your chips. Good. Then the next question is that, so am I doing a good job? Am I printing it correctly? Have you ever tried to stack any stroopwafels together? Well, you buy the box and they're over there. But if you tried to stack them on a millimeter or even a nanometer level, it's actually pretty difficult. Because when you have a wafer, let's take a stroopwafel here, okay? And then you take it and you place it on top of it, then you realize that it doesn't necessarily fit very well. Now try to put more. It could be that by the time you reach your 100th stroopwafel, this might even start tumbling and falling. Well, it's a metaphor, but chip manufacturing is not very far from this paradigm. So in fact, what is happening is that you have a wafer, you expose it, so like you burn it with a laser, then you build a second layer, then another layer, and another layer. In one of the memory that you have in your mobile phone right now, there can be up to 160 layers in just a simple memory microchip. So we want to figure out, okay, what's happening? And then we started measuring. Once again, no need to use any numbers or any figures. This is geometry. What you see right now is actually an exposed wafer. So what you see as the vector is that, well, I have my stroopwafel, then I place my other stroopwafel on top, and I try to see how well they are aligned. This is called overlay. And what you see what do you understand from these vectors? There is a tilt. It means that I placed this one, and somehow there is a drift. So the one on top is like leaning towards the right. Is it right? Or is it towards the left? Yeah, it's my left. So you see that there is a drift. There is not a direct overlay. What you see is that your vectors are kind of flying to the right. That already shows that something is happening. So I need to probably correct my machine to be able to have my vectors, my scope waffle is properly aligned. But there is a problem with this picture. Can somebody explain to me? Not you, Astrid, you know. What is the problem? I mean, what is the difficulty in this visualization? There are more than 10,000 vectors in here. You probably have seen it also before, especially if you have ever worked with scatter plots. It's overlapping. I have to render 10,000 vectors, okay? And I obviously don't have so many pixels on my screen. So what is happening? The way I'm printing those vectors, some of them are going on top of each other, right? So it does actually mean that there are plenty more vectors in this plot, but you don't see it. What if there are some vectors that are going the other way? Have you thought about it? The problem with big data, and then this goes into the so-called naive approach, if we go with just big data and say, oh, just somebody gave me this data, just throw it on the browser, this is what you get. It's good because it gives you an impression, but doesn't give you the big truth. It doesn't give you all the truth. So what you can do is that, well, maybe we can look differently. Let's try to look differently. Anybody knows how this plot is called? It's called a contour plot or a heat map. Some of them may have seen this in geography, like think about mountains. So every contour plot, it actually shows like how high a mountain is. It's like looking at the mountain from the top. So we kind of did the same thing in here. And what we found out, and that's an interesting story, red means a bigger error. This is the length of the vector. So the red regions are actually the place where those vectors are higher. And you can actually think why. Because as we place the wafer and we move it, because of because of the strength, because of the momentum that you have the biggest errors around the edges. The other thing you can also see in here, can you look at these kind of rectangles? Can you look at it? Do you see this? These rectangles are actually, it's called the fields. So these are the positions where your chips are being manufactured. So it's not that the complete wafer is one chip, but on one wafer, people are fitting in multiple chips. So it already shows how your machine is behaving. So they print one chip, then they move to the next one, then to the next one, then to the next one, and then again. So it moves like this. So it's not that it's running like crazy, but it's printing chip by chip, field by field. And then you see that the biggest errors are actually on the edges. Why? Because as you move, you have a momentum. It takes some time until that machine is ready to print. And these are the things that you would not be able to see in the previous plot. Again, it's not saying something wrong. It's not that it's lying. It's also how you visualize the data, that you tell a different story. That story you couldn't tell. Again, the data is the same. You couldn't tell unless you visualize it differently. And that becomes even more evident if you start rendering into a 3D plot. It's called a surface plot. And then you can really see the curves that are a bit different. When it comes to data visualizations, has anybody worked with, have you ever done a hobby project? So looking at the people who did data visualization, did you ever look into any hobby projects? I kind of get crazy with these things. So on my free time, I really like to look into what kind of projects I can do on my own. Who can tell me what is an irrational number? Like who is good in mathematics? Do you know what's an irrational number? Have you heard the word? An irrational number? An irrational number is, well, it's not that it's behaving irrational. It's an irrational number is a number that you cannot you cannot show, you cannot depict as a fraction. So 1 over 3 is actually a rational number. It means that it goes to 0.33333, like infinite number of threes. This is a rational number. An irrational number is actually a number that you cannot describe the digits. So an irrational number has infinite digits. But what does it mean it has infinite digits? Like 1 over 3 also has infinite digits. What is the difference with... Can anybody tell me what's the most common irrational number? Anybody knew it? Pi, exactly. Pi, or the square root of 2. That's also one of the most common, or phi, the golden ratio. But pi, let's start with pi. I like it a lot. It also smells nice. Pi is one of the most common irrational numbers. But why pi is so different than 1 over 3? Because it has infinite numbers that are not repeating themselves. But what again does that mean? Well, I wanted to look at that. I wanted to understand what it means. It actually looks like this. This is pi. These are the first 10,000 digits of pi. And what I did is that you have the digits from 0 to 9. And I tried to depict those numbers in a kind of a helix. So I'm starting with 3.1, 0.4, 0.1, 0.5. So you start with these numbers, and you start unwrapping them, like some sort of helix. And this is how it looks like. I'm showing this, why? Because for me, you can also find harmony in irrationality. Although you have endless, infinite numbers, somehow those infinite numbers are not placed in such a way that here you have a lot of threes, and here you have a lot of ones, and here you have a lot of fives. How you place them, actually, it kind of follows a certain balance. Look at this also. This is if you put them in like as a digit one next to each other. I had actually people who called me and they say, I want to have this on a t-shirt. This is where you go into art. This is where what you can start, and come on, anybody can do it. And you don't need JavaScript for it. I probably have a lot of Java developers in here. Anybody can write a piece of code that can do it. But it's actually that part that if I gave you a CSV file with 10,000 digits, I don't know if how many people can understand that those numbers are actually not repeating. Or at least they are not repeating, obviously, but they are not aggregated into one particular area. And it actually gets even more beautiful. I think that this goes into art, in fact. So in this diagram, I did the following. It's like knitting. I start by connecting one digit with the second one. So I start with 3, then I go to 1, then I go to 4, then I go to 1, then I go to 5, then I go to 9, then I do it like this. Look at this. 10,000 digits, and still, look at this, still, the numbers are almost balanced. In 10,000 digits, although you have random numbers, you are still able to display, and that irrational number still has some irrationality in it. The amount of zeros, ones, 2, 3s that you have is actually almost the same. It's not you have 3 times more ones than zeros, for instance. It still gets balanced in here. So if you log into my website to Infographer, you will also be able to find more in there. Again, I like myself to look into, I like to dig into data. And a couple of years ago, I stumbled into one of the situations that is a very practical problem. Well, maybe you know that Greece had some pretty tough time the last couple of years. And at some point in time, my parents also wanted to sell their property in Thessaloniki, in the place I come from. But when you want to sell your property, the question is going, okay, and how much should I sell it? How would you think about it? How would you do it? If you want to sell your house, let's say 100 square meters, built in 1960s, first floor, 1 bedroom, 1 kitchen, 1 bathroom. What would be your criterion? How would you define how much to sell it? Any ideas? Well, normally you could do the following. You would be looking at your peers. So you would be scouting, you would be looking into your neighborhood and say, how is my neighborhood selling? So what would be the price that the other people that live close by are selling? And then, okay, but how do I know this information? Astrid, do we have funda.nl also in... Is there a funda.nl also in Belgium? Is there like this kind of... So funda.nl is a website that you have in the Netherlands that is about housing. And pretty much, if you are selling your house, you can just upload the photos and you can upload the location and the price. And then you can scout per neighborhood, you can see what kind of houses are there. How many people have done a scraping? Or how many people know what is a web scraping? Okay. Have you practiced it also? Have you practiced it without asking a consent? Yes, we have. Yes, you have. So Greece has a similar situation. So I was trying to help my parents, and there was no way to find out statistics about housing prices. So I went to a similar website. It's called greekhome.gr. And I was trying to find out, okay, so how much can it be? And that information was quite scattered. So then the developer kind of gene kicked in, and I said, well, I can do it myself. So I made some scrapers. I used Ruby. I like Ruby a lot. But you can also do it in Python or in Java, in any kind of language. So I had a small scraper that went and downloaded like 10,000 advertisements from my city. So I just automate opening the page, like capturing whatever was on that page. So also including the position on Google Maps. And I just stored everything in a CSV file. And then I used it by placing them on it's called a GeoJSON file. That's a geometry file. And this is actually what came from. Has anybody in this room been to Thessaloniki? Has anybody knows where it is? Okay. Thessaloniki is the second largest city in Greece. It's in the north of the country. So this is the bay. That's the sea over there. And then it was actually quite interesting when I first showed it. Why? Because I almost had a feeling, but this was the first time I could actually show it. So the part that you see really dark blue, that's the most expensive property, and this is the old city. Then the western part of the city is a bit more low. Let's say the real estate value is lower, and the part on the left, so the eastern part of the city is actually way more expensive. So it shows you something that you always had a hint, but you didn't really know if that existed. And then I started digging even more. Like these are the things that starting saying that, okay, so I found on a neighborhood, what if I can find on a city block? That was actually pretty interesting, because you find out also how the city expanded. So you see that the most expensive properties are close to the old city, next to the seaside. And then you see also that on the left part, on the western part of the city, price is also lower, and here they're actually growing higher. And you can see where the properties are actually more expensive. And this was also published on the news, on the media in Greece. And these are the next thing that also start developing. Then you also got approached by real estate agents, say, hey, maybe there is an opportunity here. There is a subway line being created right now in my city. So I would say that would be an interesting map to see where I should actually try to buy some property. That already gives you a signal. In this property, in this graph, I try to show the age of your buildings. So light blue means older buildings, and dark blue means younger buildings, or more recent buildings. And you see how the city expanded. So you see the older buildings are in the city center, and then as the years have gone by, more and more houses have been built around the suburbia. So you see how your city has been expanded and how this is also growing. I don't know, I haven't seen something like that in the Netherlands or in Belgium. I don't know if you guys have seen something like this. Then the next thing that came into to my mind, so I did this for 2015, 2016, 2017, so I did it multiple years. Then I tried to compare the prices between years. So I aggregate the data in the same moment in time, and I try to compare it. Green means that the prices have gone up, and red means that the prices have gone down. And when I look at this picture, I found it quite interesting that this area, Aristotelus, that's what you see, this orange area, that price went down. And I'm trying to find out, but come on, this is the most coveted area in Greece. It's one of the most expensive properties in the whole country. It would be weird or funny to see the prices going down in that area. And this is where politics is kicking in. So in Greece during 2015, when because of the crisis, what happened is that the government, in order to increase their value, to increase their taxation, they imposed an extra taxation on high-value property. So if you suddenly had an expensive property, you had to pay more expensive tax. And somehow, owning an expensive property was not such an advantage anymore. And that was actually driving the prices down. The same also goes for that part to the upper, to the left of the screen. This is also one of the places that you had a lot of young properties. And then what happened is that because it was quite difficult to get a loan, so it was really difficult to get a mortgage from banking, you had a lot of young houses or newly developed houses, but nobody was able to buy it. So you had property that was brand new, quite overpriced as well, but if nobody is able to buy it, you see that prices go down. So if you're going to buy some property, that already gives you an indication where to look, but also where to avoid. Because if a certain area is going too down in prices, that can also mean other things. It can also mean crime, it can mean pollution, it can be so many different things. I want to start with another funny subject. How many of you have looked at your horoscope today? Hey, come on. Hey. I mean, I find it really interesting because even the New York Times has a horoscope session. If you ask people, okay, how many people believe in horoscope? Oh, nobody. Okay. But how many people have read their horoscope at least once in this month? I want to look. Okay. I mean, I'm not saying that you believe in it, but probably you have read on it. So, okay. I had a conversation with some of my friends, and it was like, people get so obsessed with horoscopes, like, oh, you're such a typical Virgo, you know, like these kind of things. Then whenever you have a conversation or you have a fight, you're like, typical Capricorn, you know, this kind of statements. Like, what do you mean typical Capricorn? This doesn't make any sense, in fact. Apparently, horoscopes are quite a big thing. I mean, at least in Greece, you see them every day. You see them in newspapers. As I said, the New York Times has a section for horoscopes. Most of the websites, if you go around, just look at your favorite website when you read for news, it probably has a horoscope session. So I'm trying to understand, we have like 50 people in this group. If nobody is reading your horoscope, who is really reading those horoscopes? And when you go down into, okay, horoscopes, I mean, you can believe many things. I mean, but whether they actually make sense? So my feeling was that, like all horoscope, they more or less say the same thing. But is it actually true? Well, this is again when the developer gene kicked in again. So I was triggered by, I will translate this. So one of the newspapers and one of the biggest websites in Greece, they had a front page that says, apparently one of the most common searches on Google, at least in Greece for last year, it was that how kids are born, how are kids made. That's kind of funny. How to seduce an Aquarius. I really found it really funny. Like, seriously? An Aquarius? Come on, I mean, Capricorns are much better, right? I mean, like, why an Aquarius? But apparently people are looking for these things. And then, well, why are men running away? Don't get me started on this. So I got poked by this. And then I found out that there was a website, one of the most common websites that people go in and read the news, young people in particular. And that website, well, I think they made a very fatal mistake. They were publishing every horoscope for every single day. If you notice, if you ever start digging into it, you will find out that if you go like to New York Times, they have the horoscope, but from the present day. It's not easy going back and say, okay, so how was my horoscope the previous day? Like, or 1 month ago, or 1 year ago. Somehow you cannot find it, and I can explain you why. Well, that website was actually not smart enough, and they were actually publishing their horoscope every day. Then what does a scraper do? They scrape. And I made a very nice scraping that was able to parse the daily horoscope for the last 5 years. That was, well, if you do the math, that's like 1,500 daily horoscopes for every star sign, you know? And, okay, I know that only that guy far away over there understands Greek, but I think you can also understand this. So I capture all the words, and I try to bundle them together. So the bigger font means the word that was appearing more often. Let's do it in English. The most common word that ever appeared on those horoscopes was maybe. Almost in every horoscope, in every day, in every prediction for every day, and in every star sign, that was always about maybe. And then you had relationship, career, love, obviously, person, good. Well, do like, okay, this is not a direct translation in Greek, but more like do this and do that. It was more like an incentive or a suggestion, try to do this or try to do that, or try to start a new relationship or try to spend more time with friends. So that was the idea. So these words appearing more and more often. So, okay, so there is a commonality apparently. So when you start going through the linguistics, you find a lot of words that are appearing quite often. I really like how this maybe stands out in here. And then the next question is, okay, fair enough. But then my friend Astrid here says that, well, I'm a Capricorn and you're a Sagittarius, and there is no way that we are the same. You know, there's no way. Capricorns have nothing to do with Sagittarius. Well, really, Astrid? Really? I mean, I did the same thing, and then apparently that pattern still kind of resonates. So, again, this is on Greek in purpose. First, because I was too lazy to translate it. Second, because you don't need to understand Greek to actually interpret it. Also, if you just go into different, so this is Aries, and this is Sagittarius, and apparently the same words kind of resonate in both kind of situations. If you have time and you go to Infography or you just try to look at it, just click on different topics, you will actually see how this behaves. And this goes pretty much for also for Scorpios and Leos. Apparently the same words are appearing in the same fashion. So we already see a trend in here. Okay, good. So you showed me that many words are appearing the same. Okay. But then why do people say you're a typical Capricorn? Why do people say this? What do they mean? Challenge accepted. Then I did the following. So I gathered all these daily horoscopes, and then I tried to find what are the unique words in every star sign. You see where this is getting, right? So I tried to find out how many words or which words in particular appeared only on the horoscope for Aries or for Leo or for Capricorns or for Pisces. Then you try to find out why such words appearing very uniquely on those particular signs. And then you got some really interesting findings. So, well, let's see. Well, for Aries, the common words, the unique words were temperamental, fight, blow up, gunpowder. So I don't know, do I sense some anger management issues? Do you have any Aries in the group? So like, please don't get offended, please. Like, then for Taurus, well, I found out a lot of conservation, a lot of conventionality, a bit of lie down. Kind of sounds like a couch potato, like the stereotypical Taurus, like, here it's fine, you know. Then for Gemini, well, this was actually had a lot of a lot of words that are appearing often. Well, again, schizophrenia is not my word. I found it in the text. So I think that Geminis tend to speak a lot. I'm not a Gemini, by the way, but they tend to speak a lot. So I don't know how many of these stereotypes you can also identify when you look into it. For Cancers, like very whiny, like maybe some sort of drama queen. Leos, well, they're very famous for their elegance and finesse, like Beyonce, I would say. Virgos. Where to start with Virgos? Like, always busy, always doing things, like really crazy with cleanliness. Well, some sort of Monica Geller from Friends. Libras, well, always undecisive. People that can order sushi and pizza at the same night because they cannot make a decision. Scorpios, very sensual people. But also very vindictive. So, well, if you see that slash in your tire, probably that Scorpio did it. So we need to look at our tires after we finish this, Astrid. Sagittarius are very overconfident. This is often called passive aggressive. And Capricorns are very much into rationality, being rational. Aquarius are very idealistic. Pisces live on their own cloud. They really like to daydream and to imagine. Do you identify these stereotypes? Like, have you found them in your stories? Have you found them that somehow that they say that Virgos are always very busy, very like freaking with cleaning, and that Aries are, well, they have some anger management issues? Have you seen this before? Well, apparently, when I started saying, okay, let's make a horoscope, because that was the idea. We want to make a horoscope. Then let's make a horoscope. Then I found out that the best thing you can do is that you can take a lot of the common words, the one that we saw repeating a lot. Then we're going to take a lot of planets, because apparently, I don't know, the moon entering Libra means something. I don't know, but they use it a lot. So, or Aries moving into, I don't know, Virgo. Yeah, people say this in a very scientific fashion, then they expect you to understand, but Aries is moving into, Mars is moving into Virgo, so apparently that's going to be a tough time for you. Like, why? Anyway. And stereotypes. So I tried to put this together, and then I made this, and I challenge you to tell me if this is something that I made or something that I copied. I have it also in Greek, but this is what you see in here is actually only words that I found out in the dictionary. I don't know shit about horoscopes. Whatever you see in this written is just the things that I wrote from the horoscopes. I place this in here, and I challenge you, especially with these data visualizations, because I think that maybe you have also understand we engage with images long before we even learn to read. Just think about it. The first time in your life that somebody showed you the picture of a dog, you knew that this was a dog before somebody has it in written, in any language. Just by the looking at the image, we are, as human beings, we are optical subjects. We understand with vision. We don't need, maybe it's part of our DNA. We don't need to read letters or to read numbers to understand. It's just that by looking at something, we are able to make meaning. We look at things, we look at images, and we try to make meaning out of it. And this is why data visualization is so important. I want you to look at this one. Already from 1984 to 1994, there was a 142% increase in the use of visualized information. The media itself is actually following this trend. We had a lot of things printed, like with numbers and with text, and now we're moving more towards an image era. Think about it. We don't read anymore. And this is only gonna get worse. Just People are actually able to select their mate, their partner, through Tinder, which means swiping left and right. It's only an image. Even that, as important as selecting your ideal partner, your partner, it's just imagine that you saw a picture and you swipe left and right. We don't read anymore. We don't need text or figures to understand. We scroll a lot, infinitely in fact, and we just need images to understand what is going on. And while this opens a lot of opportunities, it also opens a lot of challenges as well. Now, if you look at this is the Times in 1994, I think if you open the web page right now, there's probably way more content, as in visual content. And it was the New York Times, in fact, that brought the idea of dynamic infographics. So D3GS, for those who may not know, D3GS started from the New York Times. So they were the first that made these nice dynamic visualizations, as you can see. And then they were kind enough to publish their library. Have you seen this before? Even LinkedIn says that it's not about, as I said, having big data. It's the ability to make sense out of big data that can make a difference and actually can land into a pretty hot job in the job market. And the message I want to give you today is that you don't need to, for me, I don't think you even need to go to college to do that. I believe that you as programmers, as developers, as architects, as engineers, you are looking at so much data every day. It's how you process it that you can make sense out of it, you can make knowledge out of it, and maybe you can even create something more. Think about it. This is 2013, huh? Already in 2013, we hit a benchmark. More data has been created since 2013, since the entirety of the human history. Like, look at the Bible, look at all the textbooks, look at all the pictures and the images that we have, like in the oldest libraries of the world. Just in 2013, we got more data than that. Well, nobody likes, most of that data is always like clicking a like on a cat video on YouTube, but it's still data. I mean, but it shows also how we have changed also how the way we think. And I want to bring this into this image, that if you only have data, then you have something, but you need to explain it. In order to explain it, you need a narrative. A narrative is a story. That's pretty much what I'm doing right now. But even then, that story is not often sufficient. Just to tell you that visual coverage has started 142%, doesn't really, what does it mean, 142%? If you put visuals next to it, these are the image, this is the comparison, this is how you make your story really powerful. So you need to combine all these strings, and this is how you bring change, you bring awareness. Good. How many of you have tasted at least 1 spoon of Nutella this month? Okay, don't be shy. Also the others probably have, but okay. Is Nutella healthy for you? This is how it's printed on its label. So we do, as human beings, as I said, we understand data through figures. So is it healthy? How many people think that Nutella is healthy? Hey, come on. It says that it has so many hazelnuts, you know, it has milk. You see that also? Yeah? Cocoa is probably good. And it says that, I don't know, it has fibers and it has 0 cholesterol. So it must be healthy, right? So, come on. Why these kind of things, I don't see the denial here. It's so healthy, you know? Milk and hazelnuts. Is it healthy? Well, is it? Have you seen this before? This is Nutella. So those people who actually grab the spoon of Nutella, now that's your guilt time. Now I leave you some time to digest it and to understand that you have been eating a lot of sugar lately. Actually, half of that bottle is actually sugar. They have not been lying. That zero cholesterol is actually true. They don't lie, you know. That 200 milligrams of I don't know, of full fats, I don't know, in 100 grams, this is actually true. Nothing of this is a lie. But what has more impact? Visuals, images have way more impact than numbers. I hope that the people that I have in this audience, you were able to understand my screens, although I did not really show much of the facts and numbers. I didn't show any numbers or figures. Hey, you even understand Greek now, so with a horoscope. So even text or numbers are not important. Visuals can make way more impact. By show of hands, how many people think that Greenland, we know what Greenland is, right? How many people know that, how many people think that Greenland is bigger than India in terms of area, square area? How many people think that Greenland is bigger than India in terms of square area? Okay. How many people think that India is greater than Greenland in terms of area? You have been cheating or what? Well, why? Look how big Greenland is. Look at how big. Hey, look at this red spot. It's gigantic. You know, people should move into Greenland. I mean, I think Donald Trump even wants to buy it or something. It's so big, you know, it's so big, just big, really great. At India is so small. So why? I mean, India is bigger. Greenland is bigger, right? Can somebody explain to me? So, first of all, this goes on the assumption that the Earth is not flat. Are we still on the same page here? I mean, I'm not judging, but somebody needs to explain to me, maybe. So, based on what our friend is saying, and assuming that the Earth is not flat, again, on that assumption only. So, if the world is a sphere, again, only on that assumption, if you take and expand it into the paper on the two-dimensional, then indeed, the closer you are to the poles, your areas get stretched. So this is what happens to poor Greenland in here. In reality, Greenland is, India is 1.5 times bigger than Greenland. There's a website for it. So there's a website that really does this thing. So it takes two countries, places them on the exact same location, and compares them. So this is India, and this is Greenland. It's actually 1.5 times bigger. Guys, you need to understand that, again, this is not lying. This is perception. It's called the Mercator Projection. The Mercator Projection is not lying. It's only how you portray things. And I want you to remember this because nowadays, the times that are coming ahead of us, the fake news, as they call it, is not longer going to be text. It's no longer going to be some guy writing some tweet or some text and just that goes like wildfire. It's going to be images. And diagrams, those are the evilest ones. I mean, just walk around and ask them, how many people really knew? I mean, for those who thought that Greenland is bigger, I mean, we're still friends, right? I mean, that's still okay. Again, it's not that the projection was lying. It's just a different way of presenting things. So how we make our data visualizations, and I think also for you, that's a sign for everybody to now start also being twice as many critical when people put things on an image. Because if people are not looking, people are not reading, it means that they have to be way more careful into what is represented on an image. I think there is a word for it, especially on Tinder. It's called catfish. You know the term? Catfish means that to present somebody to be like on social media with a fake profile other than you. So it's really easy to be doing it. So how many people of you have watched that? Do you know the John Oliver show, The Last Week Tonight? Okay. John Oliver is one of the guys that he's choosing for pretty difficult subjects often, and he's like death penalty or I don't know, pollution, you know, and he uses metaphors and he uses comparisons, in fact, in most of his sketches. Well, I want to show you this thing, that the fact that we can use a comparison, because people compare, this is also how we learn. The fact that you can use a comparison doesn't necessarily mean that you should use that comparison. Come on. You have sound? Come on.
Quantify what is called the mortality.
Sorry. Let's start it. Sorry.
There is a huge disparity in life expectancy between black and white Americans, particularly for black men. In fact, when one study tried to quantify what is called the mortality gap, they found some shocking numbers, which this documentary chose to illustrate in the most jarring possible way.
We found over 83,000 excess deaths per year in the African American community alone.
83,000 excess deaths each year. That's the equivalent of a major airliner filled with black passengers falling out of the sky every single day, every year.
Okay, but that's such a weirdly specific way to put that. You don't need to take a number that's already a disaster and put it in terms of another disaster. 83,000 excess deaths is like 4 double-decker buses driving into each other every 6 hours. It's 32 hot air balloons exploding every minute for a week. It's the death of Princess Diana 83,000 times. I get it. It's pretty bad, I get it. Now clearly,
we as human beings, we understand data better in comparisons. And you can actually understand this also, especially when they have a public opinion. What is more powerful? When they say 33.32% of the people voted yes, or 1 out of 3 people voted yes. We understand when we are comparing things, when we are putting things together, things that understand in our mind. And the best way also to do a comparison, I think for those who might have also ever talked to management, it also helps a lot when you talk to them and say, hey, this is going to cost you, instead of saying, I don't know, 100,000 euros, this is going to cost you as much as this failed project we had last year. This is also how it sounds a lot. So this is also how, I really like John Oliver, how he also portrays it. It's also a way for us to start understanding. We can have a break, I think, for a few minutes before we go into a hands-on session. I want to invite you to look into the following websites. So D3GS, that's like a kick-ass website. I learned a lot from this, so let's, for those who haven't seen it. So D3GS, as I said, is a library that you can use to here. So D3GS was made in JavaScript, and it allows you to be able to render different sorts of data visualizations. Let's look at this one. Also geographic, but pretty much you can do anything. Any sort of geometry, any sort of from simple bar charts, but things are like this one. This is called a tree layout. So this allows you to, this actually the Java classes, I think the JavaScript classes that they have in D3GS, how differently you can model it. So you can show how many packages, it's like a tree, in fact. So it shows a hierarchy, but it does it in an unconventional fashion. And then you also show how many are on the same layer, how many are on a deeper layer, and so on. And it also allows you to do animations. Let's look at this. This is for geography. For those who are, look at this one. For those who are not familiar with D3GS, D3GS is actually really powerful. You can do amazing stuff, but it does have a bit of a learning curve. Nowadays, many people, if you want to get started, because by now I hope that many people will be excited about data and you want to play with it. If you feel that D3GS is way too big for you, you can also look into things like C3GS. Actually, I like this one. How many of you have worked with React.js? Okay, not many front-end people, I see. React is actually doing this. So React is capturing the code that you have in JavaScript. So instead of writing pure JavaScript D3GS code, you can also use the libraries. So what you do is that you feed their data in a JSON format, and this will compile it, so this will make the graphs for you. So for many of the graphs, you just take it and use it out of the box. So that's also quite powerful. So like, please don't use Excel. I mean, you can do better than that, honestly. Excel, I think it has served its purpose. You know, we can now say that we can bury it under the, the groove, but the world has moved on further than Microsoft Excel. We can do way more things than Microsoft Excel. So it's up to you to start looking at this. I like Visual Cinnamon a lot. These are things for you to get inspired, in fact. So some of the websites that also are landing into the media. I don't know if there is another. I don't know if there's any other practice we can have as developers that can land on the media so quickly than data visualizations. As I said, in theory, anybody can do it. I mean, anybody can scrape a website, gather the information, use one of the graphs and show it, and tell a story. It's not just about numbers, it's about telling a story. And believe me, people are willing to listen to your story. People are willing to, especially if that has to do with, knowing where to buy a house, or where to rent, or when not to buy a house, or whether Sagittarius are really that kind of difficult people to live with. They are willing to look into your story. So I'm welcoming you also to look at this. After the short break, we will be looking into some of the data visualizations that I also have on my website that are actively used as we speak. One is used by the New York Genome Center for the study of cancer, and the other has been used by the Greek media to model the national elections and the shifts between left and wing for the last 5 years. Let's have a break for like 15 minutes and we resume. Thank you. So I hope that at least the content is understood. So if at any moment you have any questions, if I'm going too fast, then please do not hesitate to ask. Before we proceed, I'm going to talk about two things that got intrigued during the coffee break. So one had to do with the real estate part. So there is an actual situation. So how parsing data, how visualizing data can actually lead you to more opportunities. For those who might not be aware of Zillow, well, Zillow took it to the next level. Zillow is one of the websites in the United States, like in New York, and it has taken like the work that I did into one learning step further. So what Zillow is doing is that it's not just blindly visualizing the color of the neighborhoods or the color of the city blocks. What they do is that they measure again the price, the the location, the number of floors, the number of bedrooms, and so on. And by using deep learning, they can actually calculate or estimate the price of a house, given a certain number of profile. So that has gone into such a level that especially in cities like New York and London, you first go into Zillow to look into, hey, I want to buy this apartment, I want to buy this house, and they're asking me, let's say, $200,000. Is it too much or too little? You first go to Zillow. Zillow will use deep learning to calculate if that amount of money that the asking price is actually above or below the expected value. And then that also shows whether somebody is asking too much or somebody is actually asking too low, and then it's an opportunity for you to buy. So for you guys, for those that are working with big data is not just the data that your company has in your database. That's also big data, obviously. But big data is everywhere. And nowadays you also have open data. So in many countries, in the US, but also in Europe, you can find open data for virtually anything. You can find open data about traffic, about air pollution, about crime, about real estate values. And the beauty of it is try to combine it. So if you know, for instance, that at a certain area they are trying to have some polluting factories moving out, that if you correlate that data, you will also see the impact that this can have on real estate value, for instance, and vice versa. So it's an opportunity. So Zillow is just looking at housing prices, and they can actually now estimate. They're disrupting the market pretty much, because when you first go to Zillow to see if they're asking too much or too little, this is actually disrupting the market. The same thing also can go with car values, with vehicle values. And the other thing that I spoke to one of the fellows about, that the modern fake news is not gonna be so much about tweets or text or media as in documents, but the fake news is actually nowadays gonna be about images. And some of those images, you might already know it.
Seen it so many times, I'm starting to genuinely wonder if I did. Because with just a few minutes of photoshopping, you can make it seem plausible that anyone said anything. For instance, did you know Alexander Hamilton once said, "I'm not here to make friends, I'm here to win"? Or that Marie Curie said, "After the show, it's the after party. After the party, it's the hotel lobby." I mean, they didn't say either of those things, but admit it, there is some small part of you that now thinks they might have done. It seems we have got a decision to make at this point. Either we care about the accuracy of quotes and make sure that they're correctly sourced, or we don't care at all, which is why.
One of the, I mean, come on, you probably have also seen this before, especially quotes from Albert Einstein or from Winston Churchill or from some American president that doesn't really map to reality. So this is actually happening. This is already there, and maybe it's naive right now, or maybe it's benign. Maybe it's just somebody that's trying to fool other people. But putting a quote next to a famous person doesn't necessarily make it real. It's a very important thing for us to do a fact checking. We have to think twice and think about it. Just putting the image of Albert Einstein next to a quote. Again, I think there is a quote from, well, it's attributed to Albert Einstein. They say there are two things that are infinite in the universe. So there are two things that are infinite: the universe and stupidity. And for the second, I'm not even sure about it. Maybe you heard about it. Well, this is one of those things that are running around as an attribute to Albert Einstein. Albert Einstein never really said it. But it's going on so many times in memes, in quotes, running around, that it's now, as John Oliver says, you're starting to question is that maybe it is actually true. So for us, as I said, when it goes to data visualizations, it's either we have to double check what is being presented, or it is how it is presented. that also makes a difference. It's the same information, but how you show it also makes a difference. And one of the slides I have, one of the things I have to show you today has to do with national elections and how portraying national election data actually makes a huge difference in perception and how we understand. But first we will go into a bit of a more brief subject that has to do about Cancer. How many people in this room can explain me what Cancer is? What is Cancer? Not the star sign, by the way, as in cancer in medical.
It's a mutation usually from cells, and they are growing in a not accepted way. So you got the tumors, and the cells are growing and growing without any special
Limit. Yeah. So the one explanation that we heard is that cancer is a mutation that happens in cells that lead them to having uncontrolled behavior, multiplying out of control, and eventually causing failures to the rest of the system. Mutation is only one part, in fact. What biologists use, it's called rearrangement, in fact. So mutation doesn't mean that a certain part of the DNA has just changed from CTG into CTA. It's not just that. A rearrangement means that for some reason, and by the way, cancer happens right now to our cells as they are dividing, they are also, during the division, they can also have a mutation. But that doesn't mean that mutation will survive. It could also be that our body can understand that there is a mutation and just erases it already before it grows. The way that cancer develops is that you have a rearrangement in your DNA. So if you think of it that you have the complete human DNA, the complete human genome, and at some point in time, for whatever reason, there are many causes for it, you have certain parts of the DNA that are rearranged. Rearranged could be that a part of chromosome 1 is now linked with chromosome X. It can also be that one part of chromosome 2 gets duplicated. So for while the division happens, you have this part, and suddenly on the new cell, you have the same thing twice. Or it can also be that you have this flipped. So this is called duplication. You also can have flipping. So for some reason, that part of DNA has also been flipped. It can also be part that is omitted. Like when you copy, somehow a part of the DNA is no longer there. Why this is important? Because when you have scientists, that's nowadays it's not doctors. There's a term called digital pathologists. And what they do is that they look into your DNA and they compare it with a cancer DNA. So this is about the new gene therapies. So it's called human sequencing. So you take a healthy body cell, let's say from breast. That's when normally you have breast cancer. So you outline, you have all the chromosomes and you place them one next to each other. And this is the healthy genome. Then you take one cancer cell from the tumor, and then you start doing it the same thing. So what you do is that you try to compare the cancer DNA versus the healthy DNA. And you try to place them on top of each other. And this is where you want to find out what went wrong. You want to look how cancer looks like? It looks like this. This is one of the projects that is right now being used by the New York Genome Center, one of the assignments that I did some time ago. And this is a way that you can actually identify how cancer looks like. So on the top bar, you have all the chromosomes, the human chromosomes. Then what you see as a block in here, that is a part, it's called an interval. It's a part of the DNA that was found in a cancer cell. So what they do is that normally when you finally manage to extract some cancer cells, you don't have the DNA as in a complete roll. It's not like you have a tape and you unroll it. What you do is that you have fragments. And sequencing means that you take parts of the cancer DNA and you try to find out where these are overlapping with a healthy DNA. So what you see in this one, every bar that you see in here is a part of the cancer DNA. Here. Then the question is, well, what do these red lines mean? Those red lines are actually the mutations, as our friend said. So a red line means that when I am unparsing those intervals, I'm finding out that this interval is now linked to a part of a different chromosome. And why this is important? Because this is how you can study where the mutations happen. So let's look into a certain area. Here, look at this. This is an example that you have a specific fragment in here, that this part of the base, so this part of the interval, is linked with a different part in the other chromosome, from chromosome 1 to chromosome 2. This can get pretty wild. So what they asked me to do is that up until recently, the only way that a digital pathologist was able to do it was by using R. Do you know programming language R? Okay, so R is more like Python. Is frequently used by data scientists, so it's really powerful, so you can feed in a lot of data. But the thing with R is that it generates static images. So when a digital pathologist wanted to look into, when they suspected that there was some area of the genome has there's a mutation, they had to run the code and generate, and they would get like only one part. So they would get something like this. To be able to do what I just do right now, like zooming, they would have to write code all the time, compile it, load it, compile it, load it. So now this is where I want to also speak a bit more geeky, in terms of programming languages. This is running in JavaScript. So this is actually even vanilla JavaScript. The code that you see in here is using D3.js libraries to be able to render the geometry. Everything that you see in here is an SVG. So this is an interval, like a rectangle, and then you have a line, or like it's called a Bezier line. And this is how it connects. So it reads the data from a JSON file. So you have all the mutations and the intervals defined in a JSON file, and it's able to load it and visualize it. Things like zooming, as I do in here, is actually provided by D3.js. D3.js is able to do brushing like this, or zooming. Now, let's look at this part. So, why, as I said, it's useful? Let's say for some reason, or for somehow, a pathologist would identify that, I see a mutation in chromosome 2, in this position, and I see that this is linking to somebody, linking to another chromosome. So from 2, it goes to 22. This is how the tool makes their life easier. Double click, and you are able to follow it. Most of the mutations is not even just like this. So this is a line that goes from chromosome 2 to chromosome 22. In many of these parts, you have a line that is following. So a mutation is not just this part of chromosome 1 is linked to chromosome X, but it's actually linked. That part can be linked to another part, to another part, to another part. And by doing so, we are helping digital pathologists quickly identifying what is the series of mutations. It's like, I often look at it as, it's as if you have a car crash, or you have a plane that fell, and then you have the black box, and you're trying to demystify what happened. Because this is a broken DNA. And now the pathologists are trying to find out what happened. why that DNA pieces are broken, what caused that part that is broken. And why we do it? Because the way to fight cancer is actually trying to glue the pieces together. What you see in here is that you have a part of chromosome 2 that is linked with chromosome 22. The modern day of sequencing, the way to fight cancer is that we will be creating therapies that will be able to identify that broken part and replace it. So what you will do, what we will expect in the years to come about fighting cancer, this is exactly like this. Based on tools like this, you will identify where you have the shatters, where you have the broken pieces, to help the pharmacy department make medicine that will be able to replace the broken pieces. Now, the thing is that you have a lot of red lines in here. The fact that you have a red line in here doesn't necessarily mean that this is the cause of cancer. What they're trying to do is that they will be looking at breast cancer from multiple samples. They try to find out what is causing breast cancer. Because the fact that you have a red line in here doesn't necessarily mean that you are sick or at least you are dying. Or that this is not what is causing the cancer cells to replicate. You are trying to find out what is the cause of it. And for that, you look into genes. So what they are trying to do is that when they find out a certain mutation, they are looking into certain genes and they're looking at, okay, so what is happening in here? So they will be looking into a certain gene. So a gene is a part of the DNA. It's a protein, it's a fragment of our DNA. So what they are looking into is they compare different samples and they found out that, I see this mutation, I find this red line appearing on this gene again and again and again between multiple samples. Then that already gives me a signal that if I want to fight breast cancer, this is where I should be looking into. But do you know why fighting cancer is so difficult? Because cancer is actually quite personal. It takes things personally. When we are talking about breast cancer is actually a family of different cancers that are appearing on the breast tissue. So it could be that what if we make a medicine that fixes this gene? It could work for one person, but it doesn't necessarily mean that it's going to work for another person. So what we will try to do in here is trying to identify not just what is the most common mutation that appears in breast cancer, but what is actually the reason, what medicine do we need to produce that will be tackling these specific mutations that are causing cancer. And now this is one of the examples that data visualizations are helping us to look deeper. So to look deeper. So with tools like this, we are helping digital pathologists to jump into different regions, to share the samples with others, to follow those tracks, and to look into what is actually happening. So the tool that we have in here, so I have it loaded also on my GitHub account, so you can also visit that and look at the code. Contributors are also welcomed. This is a worthy cause, so we are also helping digital pathologists to fight cancer in here. But it's one of the applications that you could also do this on a notepad. I mean, you can also write your own script in Python or in R, and you can also do these data visualizations. But the dynamic part that you see in here, this is exactly what makes the difference. That enables people to look deeper, the things that are opening the opportunity for them to look into the problem from different angles. And it's not an easy application, by the way. Good. Any questions? probably so complex that, okay, let's go into something a bit more lightweight this time. I have a story to tell. Greece has gone through quite some rough time the last couple of years. So I think that you are all familiar with it. So the last 10 years, the country, especially from 2015 and so on, 2015 was a pretty difficult year. So Greece was caught in the middle of an economic storm, let's say. Now the country is recovering, so it's much better. But what many people don't know, at least in Europe, is that what really happened in a political manner. So the last 5 years in particular, we have seen complete political shifts from left to right or vice versa that have also changed how people are looking into. Up until recently, I was trying to tell this story. I was trying to understand what happened in my country the last 5 years, and I tried to sell it in such a way that also other people can see it. When you look at the election map, this is the map of the country. So we will be going through 5 election terms. So May 2014, that was the European elections for the European Parliament in May 2014. That was the time, for the very first time, that Greece was starting to turn left. For those who have been following the news, that was already the time that the currently opposition party, the leftist party Syriza, with the then Prime Minister Alexis Tsipras, that was the moment that they have been gaining momentum. And that was because that a lot of parts of the country, they have been struggling with the whole economic climate, and for the very first time, Greece has started turning towards the left. This is also how the country started looking at. This is the first time you see so much red in the main positions. But what you actually look into is that the main economic areas, Athens, so okay, let's look at this. Athens is here. So this is where half of the population is living, actually. So 5 million people, half of the population is living in the area around Athens. Another 1 million is living in Thessaloniki, where I'm living. And then, well, the rest is actually living around the country. Already since then, we started looking at a shift. So European elections are usually the time that the public is showing their first feeling of where things are going in. So if somebody was looking at this map in May 2014, that was already like something is changing in Greece. Don't know if it's going in the right direction, but things have been going on. What has been moving the next years is actually even more. In 2015, then you had the national elections in January 2015. That was the first time that the left government in Greece actually gained power. The problem with this map, so the pink color is for the left and the blue color is for the right, for Nea Demokratia. The problem I have with these maps is that you've seen these maps also probably in elections in Belgium or in the Netherlands. What is often the problem with these maps? What is the part that they are hiding?
Well, they don't show population density.
Exactly. They don't show population density. They show the geography about who won, but they don't show. Actually, they don't even show who won. I mean, maybe here it's quite clear about who won, but even if you win by 1 vote, it becomes either red or it becomes either blue. So by looking at this, it doesn't tell you all the story. To do that, you need to dig deeper. This, what you see in here, this is actually the first time that we were able to render it. So again, I wrote a scraper and I looked into the statistics agency in Greece, and I managed to parse the data because they don't have it in a CSV format. I parsed the data from them and I managed to make this map. And I want you to look at this part. Let's go to Attica. The areas that you see in blue, these were the areas, the districts, say the municipalities in which Nea Dimokratia won. Which one do you think are the richest parts of the country? These are the things you start looking at correlations. So Syriza, being from the left, they managed to win the elections and they won the biggest part of Athens. But when you look at, if you look at the previous map, it looks like the whole Attica voted for Syriza. When you start looking deeper into it, you see that the north of Athens, which are actually the richest suburbs, and the south part of Athens, also that these are the richest parts, Nea Dimokratia was still able to win with 41% versus 24%. But it also shows how things have changed. So when you look at May, let's look at Attica, they managed to maintain it, but then things have been changing. And I'm going to look into counties as well. Counties are the really, really small district areas that were happening. So they were able, you also see how people are voting in here. This is the population density, as your friend was saying. This is the population density that you don't see when you look at the map from a very high level. This really shows how people in towns of 10 or 20 people actually voted. And you can also look the places that are the strongholds for the left or the strongholds for the right. So in January 2015, the then Prime Minister Alexis Tsipras, he wins the national election in Greece, promising that he will stop the austerity, that he will fight the economic crisis, and that he will be going to Europe to renegotiate the terms for the agreement and to renegotiate the austerity deals. And he won with quite a big margin, in fact. Also, he won the biggest area, so he lost a bit on the countryside, but he was able to win a big part. Now, for those who don't know the story, in July 2015, things got out of hand. So the support agreement actually collapsed, and Alexis Tsipras had to go back to Greece and he held a referendum. Many people maybe call the whole Grexit, in fact. But as opposed to the Brexit referendum, the referendum that was done in Greece, although 62% voted no against the agreement, well, the then Prime Minister decided to kind of ignore it and still go back to Europe and renegotiate the agreement. So let's say that contrary to Brexit, that referendum was not really respected. So then because of that, because of the referendum, then there was a second election that happened in September 2015. Let's see what happened. Let's go to districts. So what happened in September is that there was 2 months after the referendum, and what that map already started showing is that there were already some people that were feeling that something was not going well. So you have a leader that was promised that he will change Europe, that he will bring down the austerity measures, he will bring something new. Let's say that he will fight this, and then in the end you end up with a referendum that was not respected, and then you come up with a bigger and also heavy austerity program. That was the moment that already the population still maintains the vote, but something is already turning. So many of the strongholds of the left, of the right-wing party already starts developing. So part of the power has started to be reclaimed. And you might think that, well, the country voted for the left. It was the first time this was ever happening. People were sick and tired of austerity. People were looking into what is going on. Maybe we need something new. And then May 2019 happened. Now look at this. So this is just 4 years after the previous elections. In just 4 years, there has been a complete shift of the country from left to the right. And it's actually quite important. I still haven't showed you any numbers. But while in September the left won with 35%. In the European elections that happened in May this year, their percentage brought to 23%. So that's like almost 30% down below their average. So what really happened? What happened in just 4 years? A complete body have shifted so much tremendously. And what also happened then, because the whole map actually turned blue, as you can see in here, so the right wing was able to win the biggest part of the country. That forced the prime minister to go for speed elections that happened 1 month later. It happened in July this year. And that also was the part that had the government, had the right-wing government prevailed. What is quite interesting to see in this story is that European elections show the way. So in May 2014, that European elections had already show how the wave is going. European elections open the way for what is going to come. So already, if you don't know about politics, just by looking at the results from European elections, just kind of prepare the way for what's happening later on. So in May 2014, the left won, and then in the next elections, they won by a landslide, and the other way happened in the other countries. I want to show you also something else that many people in here, they're ignoring. Let's go for counties. In the last 5 years, it was not just that the political system in Greece changed a lot. It's also that next to the moving to the left, you also had a lot of extreme right-wing party really gain into seats on the parliament. The extreme right-wing, it's called Χρυσή Αυγή. That's like the pro-Nazi party. That's really like the extreme right party. They were able to even become the third party in the Greek parliament. I want the people in this room to look in this area over here. Do you know what is on that part of the map? Do you also notice that the dark purple colors, this means where that party had its highest percentages? Do you know why this is happening? Exactly. Many people don't know, but Greece is actually the borderline of Europe. It's the first entry for whoever wants to enter Europe. And what was happening in the last 5 years, and actually still continuing on it, is that you had a lot of refugee waves that are crossing Turkey, either from the borders on the north. So this is land. So this is a land barrier. And this is the sea, this is the Aegean Sea. And you see that it's exactly on these parts of the country where most of the refugee camps have been set that you had the highest increase in the extreme right parties. The other is actually here. Look at Attica. Attica. This one. The same also goes for, you might expect that the country swap to the left, but at the same time, the western part of Attica, this is also where you have the poorest neighborhoods. And on the poorest neighborhoods was exactly what you had the highest numbers for the extreme right party. If you look at the complete map, you don't show this truth. But the numbers are there, the reality is there. It's how you depict it that you look into you look into things that you didn't even know. So you see that the parts that you might expect that the left would be more common or more popular on the poorest neighborhoods of the country, and it is. But you also see that the extreme right has also been growing on that part. It's actually very fortunate in the elections that happened in July. Finally, the extreme right party is no longer in the parliament. But still, the stigma is still there. So whoever who is designing policies around well, Europe, I would say, they also need to look into these parts as well, because it's not something to be taken into account, to be ignoring it. The other thing I want to show you is that, let's go into back in here. The problem I see often with these maps is that you show things, but you don't know who won, and they don't know what they actually achieved. So I started looking into differently. Your comment was actually very useful. Population density. When you look at this map, you don't really know which parts of the country actually have the biggest population. And you also do not know where each political party won by majority or they lost by majority. So to that end, we are looking into this. I wanted to try to visualize how the country changed in the last 5 years. How do we visualize that swap between left and right? So I try to move away from geography, I try to move away from maps, and I came up with this kind of plot. Now, again, you don't need to know about the Greek geography, but what you can understand is that the bigger the blob, the bigger the circle, it means that's a district of voters, and the bigger it is means that there are more voters. So the size of the circle is also representative of the amount of voters that you have in there. This is May 2014. In May 2014, it was the left that won the party, and as you can see, the blue part, that's the right-wing party, they lost all the major districts. So if you look at, this is Athens, so this is the part of Athens, of Attica, Thessaloniki, so the biggest regions in Greece, they lost them. However, they still managed to maintain their strongholds in the countryside, and they're like, if you look at the percentages, they were even above the national average. Now look what happened. This is the elections, January 2015. This again when Syriza won. What happened is that they again lost the major districts of the country, but they managed to put their voters together. So that's also another thing that you also notice. Between European elections and national elections, well, more people turn to vote. So you see that their percentages also grew. You have more people voting, they lost, but also their percentages increased. This is September. They more or less stayed in the same situations as they had before. And this is what happened in May. What happened May this year, before with September, look at it. They went from 27% to 33% already. So this is how you see that the whole body of the electors is actually moving. So they were able to win also the bigger areas, and they were able to increase also their percentages. It's already a sign that the population is turning. So even if nobody knew what was going to happen in the forthcoming national elections, is exactly like this. They went from 31% to 39.85%, winning the majority of the votes. This already shows that in 5 years how the complete body of the voters have changed. Let's look at the opposition party. You can also find this on my blog. This is the left-wing party. This is Syriza. Already in the European elections, they were able to capture a big amount of the voters, also in the bigger districts. So they are actually the opposite, so they have very few areas that they weren't able to win. Look at this. In January 2015, the country really swiped left a lot. So they really managed to grow their percentages quite a lot. So the majority of the bigger district was able to turn towards the left. They didn't lose much in percentage-wise. And then 4 years later, this is exactly how the same electorate body managed to swipe towards the left, to the right. Although in the last national elections they managed to regain some of the power. If you look at it, if you just look at the map in terms of the geography, you cannot really read this. But this is how your voters have swiped left and right. And it's just by looking at different quality attributes that you can understand how things are moving in a country. So just by showing the same information in a different way, it already gives you things that you were not even that you're not even aware of it. Let me see if I have also for the votes. That's another thing. We also tend to look into percentages. We often tend to forget about votes. If you look at also about Brexit, that like the whole discussion that's happening, if you look at the percentage that the exit won versus the remain, if you map it into votes, that was actually not that big an amount. So often when you look at a percentage, we actually forget how many people are actually behind it. So if you say that, it's like thinking about it. What tipped the scale for Brexit was a city the size of Lancaster, for instance. That brings a new perspective into how we evaluate things. From the, 52 versus 49%, that's a different thing to look at it as in a city the size of Lancaster. That tipped the scale for an entire country. So this is also voting. How voters also changed. Syriza is increasing their votes. Look at this one. So these are the biggest areas. This is the biggest districts. In between elections, from European elections to national elections, they managed to increase the voters a lot. Then in September, if you ask me, this was the qualitative part that was missing. This is what you don't see when you look at percentages. Between January and September, being after the referendum, their percentage was exactly the same. But if you look at the voters, that already means that many voters did not go to vote. Look at this. So, if you blindly look at numbers, it could look like it was a success. You know, they got 35%, and then the next election they got a 34%. By 1%, maybe it's not that big a deal, but it shows a trend. It shows that a big part of their supporters did not bother to walk up and vote. That was already paving the way for what was going to happen. And when you look at the last elections, this is what happened. So when you look at votes, the perspective also changes. They lost big parts, and they were able, their percentages and the voters also went down. Same also, I think in the last elections they managed to regain some of the power. And finally, look at the other party again for voting. They managed to increase their percentages. They stayed it, and then they managed to reclaim some of their power again. I want to invite you to start digging. This is not something that you need to have a degree in the university to do it. Look out there. So, and also, we also need to look deeper, and also we need to demand for open data. So what you see today is not available anywhere, because that data that you see, I had to scrape them out of the website of the statistics agency to get them. This is a matter of democracy. How people vote, how people express should be open data and should belong to anybody. Because this is how we also learn and understand better about the situation that runs in our country. So it's also up to you to look into, because there are probably many open data, and if you combine them with the data that you also have in your organization, you can also get bigger insights. that concludes my presentation. Do you have any questions that you want to ask in general for the topic? You can, for those who might be interested, is that the European Union is already starting an initiative that goes for open data. And the idea is that all the countries in Europe are obliged by law to publish their public data. That goes for environment, that goes for traffic, that goes for pollution, that goes for financial, real estate. So look up to that one, because a lot of things out there, and well, who knows what kind of stories can be brought up out of it. So thank you very much. Thank you for joining.